So, we're going to start. Welcome to another section of our tutorial class. So, uh, the previous class we were doing some questions. So, then we are going to continue from here. So, the next one we are doing now is limits as x tends to 0. We have 3 tan x minus x cos x all over x squared plus sin x. Now we have this as a question. Now normally when a function tends to 0, at x tends to 0, if we input the value of 0 into this expression, we know that sine 0 is 0, and x squared, which is 0 squared, will also be 0. 0 plus 0 is 0. So which means if we put the value of x to be 0 into this function, it will be undefined. That means it will be discontinuous. So for us to do this, we have to look for a way by which we can solve this function. Then we will now limit it to 0. Now the method that we're going to use for this one is called the L'Hopital rule of limits, whereby we are going to differentiate the numerator, differentiate the denominator, then after that we limit the function at x tends to 0. So let's see what we can get from here. Now for the numerator, if you have to limit 3 tan x, 3 tan x will give us what? That's 3 sec square x. When we differentiate tan x will give us sec square x. So we are differentiating the function. So if you differentiate the numerator, so we have 3 sec square x. Now, we want to differentiate x cos x. That's minus now. Now, x cos x, if I have to bring it separately, we have x and we have cos x. What are we using? Product rule, right? Now, what's the derivative of x? 1. What's the derivative of cos x? That's minus sine x. Am I right? Okay. Now, according to product rule, then this will multiply this and this will multiply this. You now will get that if u is this and v is this is the u dx, which is 1, and this is the v dx, right? Which is this. Then we now say the product law of differentiation is what? U dv dx, which is this times this, plus what? V du dx, which is this times this. So that is what I just did here. Now, if you multiply this now, x times minus sine x, that will give us minus x sine x. Now, cos x times 1, that's plus cos x. So using the product rule, I'm able to get this. But mind you, I still have the minus outside. It will affect the two of them at the end of the day. So now if I continue with this, now, so expanding the bracket there for the numerator, I'm going to have 3 sec square x minus, now instead of minus, now this becomes plus x sine x, then minus times plus, that's minus cos x. Okay, so minus cos x. That's what I have for the numerator. Now, let's take the denominator. Now, for the denominator, we have x squared sine x. What's the derivative of x squared? That's what? 2x. And what's the derivative of sine x? Sine x is what? Cos x. That's cos x. Are we getting that? Now, if I take them all together again, that means I'm limiting the function as it tends to 0 of this denominator, 3 sec square x plus x sine x minus cos x all over. Then this one will be what? 2x plus cos x. So this is known as the L'Hopital rule. It means we've been able to differentiate the numerator separately and the denominator separately so that we can input a value for x. So as it tends to 0. Now, Sec square 0 is 1. So now wherever we see x, it will be 0. Now sec square 0 is 1. Sec square 0 is 1. Now 3 times 1, that gives us what? 3. Now this one will be, x here is 0. So 0 times sine 0, that will give us 0, right? That's plus 0. Now what is cos 0? Cos 0 is what? 1. That will be 3 plus 0 minus 1 all over. Then we have 2x, that's 2 times 0, that's 0. Plus cos x is what? 1. That's cos 0, which is what? 1. So that means we have what? 3 minus 1, that's 2. 2, that's 2 over what? Over 1. And that gives us what? 2. So the answer to this question, by limiting the function and using the L'Hopital rule, is 2. Now the next question is sine cube x cos x dx. Sine cube x cos x dx. Now, in this one, since both are odd numbers, like this one is sine cube is odd, then 1 here is odd. So we are going to take for sine, not cos. Because when we take for sine now, sine can cancel the cos. Now let's see. We are going to solve this one by substitution. This is integration by substitution. So we said let u equals to sine x, not sine cube x. Let u equals to sine x. Now, if u is sine x, now what do we do next? If u is sine x, that means du dx. Our du, the derivative of u with respect to x. Sine x is what? Cos x, right? Now, if we make dx to be the subject of the formula here, we are going to have du equals to cos x dx. Now, how do we now get dx? Dividing both sides by what? Cos x by cos x. So that means what do we have here? That means our dx, right? So that means dx equals to 1 over cos x du, or du over cos x. So we've made the dx the subject. Now going back to the question, that means we have to get the integral of sine x is what? Is u. Sine cube x means sine x everything cube. Sine square x means sine x everything squared. So that means u cube. So we have u cube cos x dx, right? But our dx is now this. That means cos x times 1 over cos x du. In such way, cos x will cancel cos x. Just like cos x over cos x, that's what's 1. So that means we are looking for the integral of u raised to power 3 with respect to what? With respect to u. Now, if we integrate u raised to power 3, according to laws of integration, add 1 to the power, then divide by the new power. So that means we have u raised to power 3 plus 1 over u raised to power over what? 3 plus 1. Yeah. So add 1 to the power, then divide it by the new power. Plus what? Plus c, plus constants. Now that's u raised to power 4 over 4 plus c. Now what's the value for u? We recall that u is what? Sine cube, sine x, right? Sine x. That means we have sine x raised to power 4, right? Over 4 plus c. But now these are sine x. We don't leave it as this. Just like when I say we have sine square x, is sine x squared. So that means we are going to have sine raised to the power of 4 x all over 4 plus c. So that's the answer to this question. I hope it's explanatory enough. All right, so the next question now, we have to find the intercept of this function. Now, intercept means for y-intercepts, when x equals to 0. For x-intercept, when y equals to 0. Now, for us to do this, first of all, let's get this function in the simplest form. Now, how can we do that? Let's factorize. For the numerator, it's the difference of 2 squared. 9 is the same thing as 3 squared, right? So from difference of 2 squared, we can say x plus 3 into what? X minus 3. That's the numerator. I'm trying to bring it separately. That's the difference of 2 squared. 9 here is the same thing as what? 3 squared, right? So when you have difference of 2 squared, which is a squared minus b squared, give us what? A plus B and what? A minus B. So we use that as difference of 2 square. We also have difference of 2 cube. But for now, this is what we are doing for this one. So difference of 2 square. Now, from here, the next thing now to do is to factorize the denominator. Now, for us to factorize the denominator, this is what we have. Now, let's bring out the denominator. We have x squared plus 5x plus 6. Now, in factorizing, we do this when it's arranged squared, x, and the constant. So the coefficient here is 1, this one is 6. And the b here is what? 5. Like these are A, B, and C. All right, so now, so we said that it's going to be 3 and 2, because 3 times 2 will give us 6, then 3 plus 2 will give us 5. So these two now, these 3 and 2, we substitute for 5x here. So that would be x squared plus 3x plus 2x plus 6, because this and this will give us this back. So now, taking what is common between x squared and 3x, that's x. So x into, if we take x from this, that's x plus what? Plus 3. In fact, in factorization of algebraic function, repeat this bracket first. That's x plus 3. Now, what remains for x to be 2x? That's what? 2. If you check 2 times x, 2x, 2 times 3, 6. What's the sign we are given? Plus. This will give you this back. So if you take what's at the front, that's x plus 2. Then what? One of the brackets that is the same, x plus 3. So we have factorized the denominator. Now let's come back to the question. Y equals to, now numerator has been factorized with difference of 2 squared to get what? X plus 3, x minus 2. X plus 3 and what? X minus 3. X plus 3, x minus 3. Now denominator has been factorized to get x plus 2, x plus 3. X plus 2 and x plus 3. Now from here, since brackets and brackets, x plus 3 can take x plus 3. So we have y equals to x minus 3 over what? X plus 2. Now, let's get the intercept. Now, when x equals to 0, what is y? When x equals, that means y equals to minus 3 over 2, which is what? Minus 1 over 1 over 2. That's the y-intercept. Now, what about the x-intercept? That's when y equals to 0. Now, when y equals to 0 in this function, that means 0 equals to what? X minus 3 over what? X plus 2, right? If you cross multiply, this will multiply 0. You know, 0 is 0 over 1. So this will multiply 0. That means we have x minus 3 equals to 0. That means x equals to what? 3, positive. So this is the y-intercept, and this is the x-intercept. All right, so now in this next question, we have to limit 3x cubed plus 5x squared minus 3x all over 4x plus 2x squared minus 9x cubed as x tends to infinity. Now, there are two methods of doing this. Now, let me give you the general method. Then after this, I'll give you the shortcuts of what to know, where you are dealing with limits to infinity. Now, let's go. Limits to infinity. The highest power here is what? X is power 3. So we divide 2. So we divide 2 by x is power 3, by the highest power of the coefficients. So that's of the variable rather. So 3x cubed over x cubed plus 5x squared over x cubed minus 3x over x cubed all over 4x over x cubed plus 2x squared over x cubed minus 9x cubed over x cubed. Right? Now this takes this. 2 of these takes 2 of this, remaining 1. Then 1 of these takes 1 of this, remaining 2. Yeah, 1 of x takes 1 of this, remaining 2. 2 of these takes 2 of this, remaining 1. Then this cancels this, as you can see. So that means we have 3. Here will be 3 plus, this will be 5 over x. You know, x squared over x cubed. That's remaining 1, that done. Minus 3 over what? X squared. Because 1 x is up. Then 3 of the x is down. So remaining 2 down there. Same thing here, we are going to have 4 over x squared plus 2 over what? 2 over x minus what? Minus 9. Now, what do you now do? You now say as x tends to what? 0. So wherever you see 0, wherever you see x will be 0. So that means you have 3 plus 0 minus 0. This will be 0, this will be 0. Like, now, as it tends to 0, even though it's not like 5 divided by 0, no. But the main function itself that is having that x will be 0. That's what it means. The main function that is having that x will be 0. This main function that is having the x will be 0. Then all over this one also, this main function will be 0. This main function of x will be 0. And this one minus 9. So at the end, what do we have? We have 3 minus 3 over 9, right? Minus 3 over 9. And 3 goes, that's minus 1 over 3. Now, this limits to infinity. But now there's a shortcut for this. If you have x raised to power 3 over x raised to power 3, if you have x raised to power 3 over x raised to power 2, and if you have x raised to power 2 over x raised to power 3. Now, I want to explain for each of these. Now, when you look at the question, and the highest power of the variable is both at the numerator and denominator. Here we have x cubed. It is up and it is down. It's the highest one there. It's up and it's down. What you just have to do, if you have ax cubed and bx cubed, what you just do is to what? Just take their coefficients. That means here we give you what? A over b. Now let's look at the question. The highest power of x cubed here is 3. The highest power of x cubed here is minus 9. That's 3 over minus 9. Do you see that? That's minus 3 over 9, which is minus 1 over 3. So without even solving, you can solve limits to infinity. If the highest power for the variable is at the numerator at the same time as the denominator, so just take the coefficient, but with the sign. The sign for the numerator is positive 3. The sign for the denominator is what? Minus 9. So that's 3 over minus 9, which is minus 3 over 9, minus 1 over 3. That's limits to infinity. But now, what if the highest power is at the numerator only and it's not at the denominator? Are you getting that? So that means at the end of the day, we are going to have 3 over 0. Yeah. So, and 3 over 0 will be what? Undivided. So when some of these questions can be in objective, just to test your knowledge on limits to infinity. So when the highest power of the variable is at the numerator and it's not at the denominator, for example, you can have x raised to power 4 up, like x raised to power 4, x raised to power 3. And in the denominator, you can have x raised to power 2 as the highest. So that means what is up is greater than what is down. So that would be over 0, and that would be what? Undivided. But what if the smaller one is up and the bigger one is down, like x raised to power 2 up, then x raised to power 3 down? That means your answer will be what? 0. Because at the end of the day, you have maybe 0 over 5, 0 over whatever the coefficients of this. So 0 over something, and that will give us what? 0. So this is what you use for limits to infinity. Once it's the same power, up and down, just take their coefficients with the sign at the front of it. So that's limits to infinity. Now, in this next question, it says we have to find the integral of 7 all over 2x squared plus 2x plus 5. How do we solve this question? Now, this is what we are going to do. We are going to factorize the denominator. But when you look at it, can it be factorized? 5 times 2 is 10, right? Now, what can we multiply to give us 10? And at the same time, we give us 2. Nothing. 5 times 2 is 10. But 5 and 2 cannot give us 2. What else can give us 10? It's only 5 and 2 and what? 10 and 1. And those 2 cannot give us 2. Now what can we do? We use this method of computing the square method to factorize it. Now let me show you what to do. Now if you bring out the denominator, that's 2x squared plus 2x plus 5. Now you might have seen questions like this. Yeah, this is what you do. If the denominator cannot be factorized, so this is what you do here. We are going to do it in such a way that we are going to have it as a perfect square, left and right. Then we are going to use the formula for arctan to solve it. Now, first of all, let it be only x squared. Only x squared. Now, what can we do? We divide 2 by what? By 2. That means we are going to have x squared, like over 2, plus 2x over 2, plus 5 over 2. Right? Am I correct? Okay. Next is going to be what? X squared plus what? X squared plus, we invite 2. Mhm. So this is the best way to do it. So we divide each of them by 2, then multiply by 2. At the end of the day, the 2 of them will cut. Eh. So x squared plus 2x, 2 over 2, that's x, plus x, right? Plus 5 over 2. Everything square. Now, if you want to check if what we did is correct, multiply this by 2. Correct, right? Okay. So that's what you do. Because x squared has to be on its own. Assuming the question here, x squared is on its own, we go to the next step. But since x squared is not on its own, we divide through by this coefficient, then multiply by that same coefficient. That's what we have here. Now, what's the next thing? According to completing the square method, we are going to find the half of b. This one here is b, right? Half of it, like the coefficient of x, half of it, then we square it, then we add it to we square it, then we take it away from there. Now let's see. Half of coefficient of x here is 1, right? Half of 1 is what? 1 over 2, right? Then we square it. But at this way to be x plus 1 over 2 squared, right? Plus we have 5 over 2 minus. Now, half of 1, coefficient of x here is 1, right? That's 1x. That's 1 over 2. Then when we now square 1 over 2, that will be what? 1 over what? 4. But let me write it 1 over 2 squared here first. So this is the first step in converting it to perfect square. Assuming what we have here is 4. If it is 4x, that will be 4 divided by 2, that's 2. The 2 will be here. That will be x plus 2 squared. Then that 2, now 2 squared will now be here. We take it away from this one. Do we understand? Or okay. Now, if the sign here is minus, this sign will be minus. This is the only thing that will change. This will remain as this. If the sign here is minus, then this one will be what? Minus. Okay. Now, from here, what do you do next? That means you have x plus 1 over 2 squared. Now, this minus, that's plus 5 over 2 minus what? 1 over 4. Am I right? 1 over 2 squared means 1 square, 2 square. Now, if we subtract this, the LCM is 4. 4 into 2, that's 2. 2 times 5, that's 10. 10 minus 1, right? So that means we have x plus 1 over 2 squared plus what? 9 over 4. So this is the same thing as this denominator. We have factorized it. But now when you look at 9 and you look at 4, they are perfect square, right? Now, at the end of the day, we can rewrite our question to be the integral of 7 over. Now, don't let us forget this 2. This 2 that is at the front. The 2 will affect everything. That 2 is very important. It will affect everything. So 7 all over 2 into, right, x plus half squared plus what? 9 over 4 squared. But now, what is 9 over 4? 9 over 4 is what? 3 square, 2 square. 3 square, 2 square, right? And if you factorize out the square, that means you have 3 over 2 squared. Am I correct? Yes. So 3 over 2 squared. So 3 over 2 squared is the same thing as what? 9 over 4. Now, if you continue from here, bringing out the coefficients, that means we have 7 over 2 into the integral of 1 over x plus half squared plus what? 3 over 2 squared dx with respect to x. Now, according to some of the laws of integration, we can do something here by saying that using this law, if you have 1 over a squared plus x squared, it gives us what? Integral of 1 over a squared plus x squared dx. It gives us what? 1 over a, right? Tan inverse or arctan, what? X over a, right? Plus c. Do you remember that? Okay. So that is something we are going to do here. A is the one that doesn't have the variable x. X is the one that's having the variable X. Now, our X here is this O bracket. Our A here is this O bracket. The 7/2 is the coefficient that's outside. So that means we're going to have 7/2 into, now 1/A. That's 1 over this one. Our A is the bracket. That's 1 over what? 1 over what? 3/2. Right? 1 over 3/2. And what is 1 over 3/2? Inverse of 3/2 is what? 2/3. So 1 over 3/2 is what? 2/3. I'm sure you know how I get that now. So 1 over 2/3 is what? 2/3. That's 1 over A. Then tan inverse or arctan. Now our X now. X is this O bracket. That's X plus half. Not without the square. All over. Now our A is what? 3/2, right? Our A here is 3/2. Now plus what? Plus C outside. Now let's continue. This will multiply this. Now 2 here 1, 2 here 1, right? So that means we have what? 7/3 tan inverse of. Now this place, you have this one divided by 3 divided by 2. Just like saying A divided by what? B 3. So let's say our A is this one. So divided by 3/2. That means A divided by what? 3/2, right? And in fraction, division turns to multiplication. That's A times what? 2/3. That means 2 will multiply A. That's 2A/3. So 2 will, this 2 here, we multiply this bracket, then 3 will be the denominator. That will be 2 into what? X plus half all over what? All over 3 plus C. Now, if we continue, this will give us 7/3 tan inverse or arctan. 2 times x, that's 2x. 2 times half, that's 1, right? 2 we cancel 2. That's plus 1/3 plus C. So this is the answer to that question. For the integral of 7 all over 2x squared plus 2x plus 5. So that's the process of doing this. All right, next question. We are going to find the domain of f of x equals to 4 all over the square root of x plus 2. Now this one is quite simpler. You remember the laws of domain. When it's a fraction, for laws of domain, okay, let me recall. When it's a fraction, a over b, that means b must not equal to what? 0. When it's roots, like square root of a should be greater than or equal to what? 0. Then when it is logarithm, like log a has to be greater than what? 0. So these are some of the laws of domain. Now, if you are to use this for the question now, so we say for domain, now we have 4 over the square root of x plus 2. Okay, first of all, we have the square root. Yeah? So let's do the square root first. So we have root x plus 2. Now, what do we say about root x plus 2? A should be greater than or equal to 0. What's our A? What's in the bracket? That means x plus 2 should be greater than or equal to what? 0. That means x should be greater than or equal to what? Minus 2. So that's the first thing. Now, but that's for the roots. Now we also have for the fraction, which is 4 over what? The square root of what? X plus 2. Now what do we say about fraction? The denominator must not be 0. What's the denominator? Root x plus 2 must not be what? 0, right?
So I had an issue with the sound, so I'm putting a voiceover for this part. So we have x plus 2 not equals to 0. So that means x not equals to minus 2. So x should be greater than or equals to minus 2. At the same time, x is not equals to minus 2. So now, how do we now get this? So in set notation, now we said x should not be minus 2, and also x should be greater than or equals to minus 2. So in set notation, the domain D is given as x is an element of all real numbers, s is an element or a subset of all real numbers, R. So firstly, let's bring out the function. Now, x should be greater than or equals to minus 2. At the same time, x should not be minus 2. So in the conclusion, that means x should be greater than minus 2. So if x should be greater than minus 2, and it should not be equal to minus 2. So that means x greater than minus 2. So we remove the equal to instead of greater than or equal to. So it does be x greater than minus 2. So that's what we have for this domain. So when x greater than minus 2, so that means it's going to start from minus 2 upward. So that means figures greater than minus 2. That will give us a minus 2 less than x less than infinity. So it means we are going to get values from minus 2 upward. But minus 2 will not be included. That's why the equal to there, we did not have it here. So it's not minus 2 less than or equal to x. So it will minus 2 less than x less than infinity. Meaning that x is a number that will start from minus 2 upward, but minus 2 itself not included. So this is how we get the domain for this particular question. So you can see there, we have two things. We have the square root and we have the what? The fraction. So when it's square roots, we can get numbers greater than or equal to what? 0. So that's how we do for that part. Now, in this question, we have to find the area under the curve. I also have issue with the sand here, so I'm adding a voiceover instead. So we have to find the area under the curve. 3x cubed minus 5x squared plus 6x as x tends from 0 to 2. Now, this will give us integration. It means we have to integrate this function. Now, you have 3x is a curve. That's a trinomial. When we have a curve, it means we have a parabola. So this is how a parabola looks like. As a curve, it can be as like N shape or as a U shape, based on whether it's positive or negative. So that's a trinomial. A trinomial will give us a parabola. While a quadratic will give us an arc. Quadratic will give us an arc, not a curve. So quadratic will give us an arc, while a trinomial will give us a parabola. Now, this is how a quadratic looks like as an arc. Then we also have the linear. Linear will give us a straight line graph. Now, the linear will give you maybe you are doing a graph of like 3x minus 2. That's a linear graph. Then a graph of 3x squared plus 2. That's what? An arc. That's quadratic. Then trinomial. Trinomial will give you a parabola, which we can give it a trinomial like 3x cubed minus 5x squared, like that question now. So this is how now to get the area under the curve. So the area under this curve will be gotten through the integration method. It means you have to integrate the function as it tends from 0 to 2. Now let's solve the workings, the question, and see how we can get the answer. Now, given this now in formula form, we're going to have integral as it tends from 0 to 2, 3x cubed minus 5x squared plus 6x dx. That's with respect to x. So we're going to integrate this with respect to what? To x. Now, 3 is the coefficient, 3 out into brackets. Now, what will give us, what's the integral of x cubed? We add 1 to the power, then we divide by the new power. That's x raised to power 4 all over what? Over 4. Add 1 to the power, divide by the new power. Now, as it tends from what? 0 to what? To 2. Minus 5 is the coefficient, minus 5 into x raised to power 2. 2 plus 1 is what? Is 3. That's x raised to power 3 over 3 as it tends from 0 to 2. Plus 6 is the coefficient also into x. X there is raised to power 1. 1 plus 1 is what? Is 2. That's x raised to power 2. X raised to power 2 all over 2 as it tends from 0 to 2. Now, for indefinite integration, there will be no constant, no plus c. Now, we continue to put the values now. So there will be no plus c. Now, as it tends from 0 to 2, we put when x is 2 minus when x is what? 0. That's 3 into the bracket, 2 raised to power 4 over 4 minus 0 raised to power 4 over what? Over 4. We close the brackets. Now, minus, that's as it tends from 0 to 2. We put 2 minus, we put what? 0. Now, the next one now, minus 5 into, now, 2 raised to power 2 over 3, 2 raised to power 3 over 3, then 0 raised to power 3 over 3. We close the brackets. Now, plus 6 into 2 raised to power 2 over 2 minus 0 raised power 2 all over what 2. We close the bracket. Now you know 0 raised power 4 raised power 2 raised power 2, 0 is 0. Divided by 4 divided by 3 will give us what? 0. So that means this one's that's minus 0 minus 0 minus 0. Now 2 raised power 4. Now we now expand this one and solve. So that means you have 3 into the bracket of 2 raised power 4 is 16 divided by 4. Then minus 5 into 2 raised power 3, that's 8 divided by 3, plus 6 into 2 raised power 2, that's 4 divided by 2. Now, let's expand. I'm trying to make it simpler so that we can understand the steps one after the other. Now, 16 divided by 4, that's 4. 4 times 3, that's 12. 12 minus, now this one cannot cut, so 5 times 8, that's 40 divided by 3, plus, then 6 times, now 4 divided by 2, that's 2. 2 times 4, that's 12. 2 times, I made the mistake there. 4 divided by 2 is 4 divided by 2 is 2. So 2 times 6, that's 12. 12 should be there, not 18. Please correct that. So that's 12. 12 minus 40 over 3 minus 12. So I will still have, 12 we cancel 12, right? So I will have 40 divided by 3, right? I will have 40 over 3. And 40 over 3 give me 13 known number 1 over 3. So my answer is supposed to be 13 known number 1 over 3, not 16. So you should correct that. So 13 known number 1 over 3.
Turning point of this function, x cubed minus 6x squared plus 9x plus 2. Now, how do we find the turning point? Turning point means we are going to find the minima, maxima, and the point of inflection. The minima, the maxima, and the point of inflection. Now, the first step now is to find its derivative. We are going to find the y dx of the function. But firstly, let's say, so we say let y to be the function, minus 6x squared plus 9x plus 2. Now, let y to be the function. Now, how do we now get this? So that means our dy dx, first derivative now, dy dx will be what? 3x squared. 3 multiply the coefficient and take a 1 from the power. Minus 6 times 2, that's 12x. 2 minus 1, that's 1. So 12x plus what? Plus 9. That's the first derivative, right? Okay. Now, after getting the first derivative, so we now say let's dy dx. So the first derivative will be 0, so that we can get two values for x. That means 3x squared minus 12x plus 9 equals to 0. Now, for me to factorize this, I can see something is common instead of me using big numbers. 3 is common. It's a common multiple here. So if I say 3 factorized out, I'm having x squared minus what? 4x minus plus what? Plus 3, right? Equals to 0. If I divide both sides by 3, that means I have x squared minus 4x plus 3 equals to 0. So I can get my x from here now. Now, mind you, this is only applicable when it is equals to 0. If it's not equal to 0, you may not be able to do that. But when it's equal to 0, we can factorize out the 3. Then 3 cancel 3. Like 0 divided by 3, that's 0. So now, factorizing this, these are a and these are b. That's 1 and 3. 1 times 3 is what? Is 3. And b here is what? Minus 4. What do we multiply together to give us 3? And add together to give you minus 4. That's minus 3 and what? Minus 1. Minus 3 times minus 1 give us plus 3. And minus 3 minus 1 give us what? Minus 4. So that means we have x squared minus 3x minus 1x plus what? Plus 3 equals 0. These two we substitute for what? This one here. Then we're taking what is common. That means we have x minus 3. Now, x is common between x squared and 3x. That's x is common. That's x minus 3 will be left. And I said in factorization, repeat the bracket first. X minus 3. Now, what is common is just 1. Minus 1 now. It's not plus because if it's plus, we cannot get this one back. So if it's minus, minus 1 times x minus 1x. Minus 1 times minus 3. That's plus 3. So that means we have x minus 1 and what? X minus 3 equals to what? 0. So x minus 1 and x minus 3 equals to 0. So now from here now, we can continue. So we have x minus 1 and x plus 3 equals to 0. So from here, going forward to the next part, we need to get x itself. So that means x minus 1 equals to 0 and x plus 3 equals to 0. So x minus 1 equals to 0 or x minus 3 equals to 0. So if you take this, that means x equals to 1 or what? Or 3, right? Now, we've gotten the two values for x. But now the same thing, we also need to get the two values for y. We've gotten two values for x, we need to get the two values for y. Now, we are going to put it into the function itself. So when x equals to 1, that means y will be what? 1 cube, that's 1 minus what? Minus 6 plus 9 plus 2, right? 1 cube minus 6 into 1, since it's 1, it will still give us 6, this will still give us 9. So when x is 1, we're going to have what? This will give us 10 and 12. 12 minus 6, that's 6. Am I right? Yes. So 12 minus 6, that's 6. So when x is 1, y is what? 6. That means the first one, x1, y1, will be what? X is, that's 1, comma 6. So this is the first point. Now, the second one now, when x is what? When x is 3. Now, putting x is 3 here, that means we are going to have y equals to what? 3 cube, right? 3 cube minus 6 into what? 3 square, right? Plus 9 into what? Into 3 plus what? Plus 2, right? Now, 3 cube is what? 27. 3 times 3, 9 times 3, 27. That's 27 minus 3 times 3 is 9. 9 times 6 is what? 54. Plus 9 times 3 is what? 27 plus what? Plus 2. Now, 27 plus 27 is 54. 54 minus 54, that's 0. That means y is what? Y is 2. So now we also have x2, y2 to give us what? What's the first? 3, comma what? Comma 2. So this is the first points, x1, y1, 1, comma 6. The second point, x2, y2, 3, comma 2. Now, the next thing now is to get the minimal and the maximal value. How do we now get the minimal and the maximal value? Now, to get the minimal and the maximal value, we are going to find the second derivative. That's d square y over the x square. Now, this is the first derivative here, which is 3x squared minus 12x plus 9. Now, if we find the second derivative of this, that will give us 6x. Now, minus 12x will give us what? Minus 12 when we differentiate. So we have 6x minus 12. That's second derivative. Now, for second derivative, we are going to put the two values of x, which is what? 1 and what? And 3. So let's put 1. So when x equals to 1, and so this second derivative, that means the square x, the square y dx square will give us what? 6 minus 12. And 6 minus 12 is what? Minus 6. Now, when we look at minus 6, is it greater than or equal to 0? Now, minus 6 is what? Less than 0. So since minus 6 is less than 0, now when it's less than 0, that's the maximum point. When it's less than 0 is the what? Maximum point. And when it's greater than 0 is the what? Minimal point. Right? Now, let's get the other points. Now we've gotten when x equals to 1. What of when x equals to 3? Now, when x equals to 3, if we put it into the second derivative also, that's the square y over the x square equals to 6 into 3 minus 12. 6 times 3 is what? 18. 18 minus 12 is what? Is 6. Now, 6 is what? 6 is greater than 0, right? Now, 6 is greater than 0. Now, as 6 is greater than 0, that means we are going to have what? Minimum. Now, this is the minimum points. We've gotten the maximum and the minimum. But before I continue, let me also get the point of inflection. For the point of inflection, after that I will conclude. Now, the point of inflection is at second derivative. So when second derivative equals to 0, now let's see. If the square y over the x square is equals to 0, what's the square y? Second derivative is what? 6x minus 12. If it is equals to 0, that means 6x equals to 12, right? That means x equals to what? 2. But now, if x equals to 2, we still need to get its value for y. Now, from the question now, let's get its value for y. That means y will be equals to 2 cube, right? Minus 6 into 2 square, right? Plus 9 into what? Into 2 plus what? Plus 2. Huh? Now, what is 2 cube? 2 times 2, 4 times 2, 8. That's 8 minus 2 cube is 2 square is 2 times 2, 4. 4 times this, that's 24. Plus 9 times 2, 18. That's 18 plus 2. Now, let's see. 8 minus 24 plus 18 plus 2. That gives us what? 4, right? So if you have 4, that means y equals to 4. That means our point of inflection is what? 2, 4, right? Now let's now conclude based on everything we've been doing. Now, what's the maximum point? Now, the maximum point is at what? Now, what do we use to get us the maximum point? This is the maximum, right? Now, what do we use to get maximum point when x is 1? Which one is x is 1 here? This one, right? So our maximum point is 1, 6, not minus 6. The x that we use to get the maximum points, that's its coordinates. So 1, 6 is the maximum point. That's the maximum. Now, what is the minimum point? What's the x that we use to get the minimum? Which is what? Minus, which is 3. Where is x being 3? This one, right? That's 3, 2. So our minimum point is 3, 2. Right? Now, what is the point of inflection? Point of inflection. Our point of inflection will be this one. When divide the x, the second derivative equals to 0, which is 2, 4. That's 2, 4. So these are the points, these are the turning points. So turning points means you should find the maximum, the minimum, and the what? Point of inflection. So that's what we have for that. And although we can also be asked to sketch the graph, we can also be asked to sketch the graph. So in further tutorials, I'm going to explain that on sketching the graph. So that's all for this one. Do follow, like, share for more exciting questions and workings.